This is question 2 from outcome 1, worksheet 4 from math 3, second derivatives with implicit differentiation. Now, pretty quickly in the question, we're looking at second derivative. That's exactly what it asks us to find. So in such a question, we'll always begin by finding the first derivative first. So I'll write this here, first derivative. And we find this by taking d by dx, so the derivative with respect to x of each term in our expression. D by dx of xy equal to d by dx of 8. So derivative of x squared with respect to x is 2x. Derivative of xy with respect to x, well, it's a product. So we're going to use the product rule. We'll take x as our u and y as our v, and we'll take x times the derivative of y. So that's going to be 1 times dy by dx, because we differentiate with respect to y and get 1 multiplied by dy by dx, because we're working in y instead of x. And to that we add y times the derivative of x, and the derivative of x is 1. So we just have y by itself. There, y times 1 is y. And on the other side, derivative with respect to x of 8 is 0, because 8 is a constant. And its derivative is always going to be 0. So tidying up here, we have 2x minus x dy by dx minus y is equal to 0. And then we can take the dy by dx term with the x across, swap over to get 2x minus y. And then lastly, divide through by x to get dy by dx is equal to 2x minus y over x. And so I'll put this in a little box to say, something left over from another question there, there's a little box to say this is our expression for the first derivative. Now we can take this expression for the first derivative and differentiate it again, and that's fine. We can use the quotient rule on the right hand side here, or we can look above and say, well, hang on, this might be a little bit neater to deal with this expression here to find the second derivative. So both paths lead to the correct answer. I'm going to take the path above and use the product rule. So let's have a look at what this gives us for the second derivative. Second derivative then. Well, I'll write that out in full. X dy by dx is equal to 2x minus y. So taking the derivative of each side, d by dx of x dy by dx is equal to d by dx 2x minus d by dx y. So let's deal with this in order. So on the left-hand side, again, we're going to be encountering the product rule with x times dy by dx. So let's take x times the derivative of dy by dx, so that's x times d squared y by dx squared, and then take dy by dx times the derivative of x. Well, the derivative of x is 1, so we're just left with dy by dx, because dy by dx times 1 is dy by dx. On the right-hand side, the derivative of 2x with respect to x is 2, and the derivative of y with respect to x, well, it's 1 with respect to y, so with respect to x is 1 times dy by dx. We're left with minus dy by dx here. So we can take our expression for dy by dx on the left-hand side and take it across to give us x d squared y by dx squared is equal to 2 minus 2 dy by dx, because we've got 1 there, we've taken 1 across. And then we might be thinking, what do we do now? Well, what we do now is, remember, we have an expression, and it's in the red box on the screen just now, for dy by dx. So we can write x d squared y by dx squared is equal to 2 minus 2 times 2x minus y over x. And we can multiply that 2 out. We get x d squared y by dx squared is equal to 2 minus, careful with our signs on top here, but we're going to have, well, we can actually change this round, make it plus. We're going to have 2y minus 4x. So if you can't see y, that's going to be minus 4x plus 2y. The minuses combine to make a plus. We just swap them round. And that's going to be all over x. Now, at this point, we could just stick in the numbers we've been given. We've been given 3, 4 as a point, and if we put all these numbers in for x and y, it will all just work out. We'll get something, and that would be a completely legitimate way to solve the problem. But I think we want to aspire to something a little bit better here. So we're going to try and simplify this as if it was our answer, and it gives a nicer expression at the end. So we'll still have x d squared y by dx squared on the left here, but let's multiply the number 2 by x over x. It becomes 2x over x, that's still 2, plus 2y minus 4x over x. And you can hopefully see straight away that we can just combine those two fractions because they have the same denominator to 2y minus 4x plus 2x all over x. But actually, I can skip a step there because I know that minus 4x plus 2x is going to be minus 2x. Let's write it like that, minus 2x over x. And then I can divide through by x. And I'll be left with 2y minus 2x divided by x squared. And that's a much nicer expression to end with. And if we were doing the question where we weren't working out the value, we'd want it to look something like this. But we are working out the value. So at the point 3, 4, d squared y by dx squared is equal to 2 times 4 minus 2 times 3 divided by 3 squared, which is equal to 8 minus 6 over 9 equal to 2 over 9. And that answers the question about what the second derivative is at the point 3, 4.